Nintendo Switch Lite. Let's see what's going on. Rule number one, we always check the port first, and the port has seen better days. That plastic in the middle is pretty loosey-goosey. You can see a couple of lifted pins, but nothing is crossing, nothing is bent. I think it's okay to stick power to it, but we're probably going to have to address the port as well. We're going to stick the benchtop PSU to it just so we can see what's going on. And the battery is dead. So when the battery had a charge, it was definitely posting the error code 2101. So we had two things going on with this one, I believe. But the first thing we need to deal with is the port. And in order to do the port, we're going to disassemble it entirely and go from there. We're going to warm the adhesive on this foam at 130 degrees. It's usually enough to get it up, and this is really old. Yeah, this stuff is a little bit old. Slight tearing, but nothing too bad. Okay, we're set up to remove our port, and in order to remove our port, I must set up my equipment, and while I set up my equipment, let me throw up my expected temperatures for this job. These temperatures are brought to you by the associate links in the description. If you go to my video description and click on one of these links and buy any of this equipment, a small portion of that purchase will go to supporting the channel. I greatly appreciate you, and it won't cost you an extra dime. If anything's touching inside this port, it would interfere with our testing. Let's get it off here. Let's bring the sauce. We're going to concentrate on wetting those anchor points first. This being low melt, it will wet pretty quickly. And then we'll concentrate in on where the pins are located on the other side of the board. And once they've wetted, the port should just drop freely. There we go. Nice clean pull. Before this cools down too much, I'm going to go ahead and just suck the solder out of these anchor points. Might as well while we're here. Beautiful. These are our common fault testing zones on the Nintendo Switch Lite. We'll start on the M92T36, work over to the BQ24193, and down to the fuse port area on side A. Let's begin our testing around the M92T36. Find ourselves a ground. We're going to test these capacitors that are surrounding the chip, and the lines we're concerned about are the lines that are actually going to the capacitors from the chip. Those are the sides we do not want shorted to ground. Okay, we do have one that is shorted to ground here, indicating we have a problem with this chip, which we kind of suspected because of the error code it was throwing. On this capacitor, it has two lines going to the chip. In that case, you only want one line to have a pathway to ground. And it does. We'll move to the BQ24193. Some checking there. Everything is checking out okay. Check our invincible fuse. It's still being invincible because in the Nintendo Switch, the M92T36 is the fuse. Now we're going to switch to side B and check out our test pads. The test pads can often indicate a problem even when the capacitors around the chip does not. Let's find ourselves a ground. That's a ground pad. Okay, so this one is shorted to ground as well, and we know from prior experience that this pad is also connected to the M92T36. So, we definitely have a problem there, and we'll have to solve that before we deal with the port. So we have two problem zones, our M92T36 and the port here on side A. Go ahead and remove our chip. And put another one on. And we're looking for all those pads to wet before we even try to handle the chip. We wet our solder. We're looking for that center pad to wet. No point in even trying to place it before that center pad wets. We're just going to fling it off into another dimension. Make sure the solder grabs. Center up. Remove your heat. Let it tack down a little bit. A little bit of downward pressure, re-wet. And squish it down. Oops, didn't want to move it though. Shoot. I'm a little rusty. We'll be alright. It was a dead holiday season. Clean up. Check our work. Pretty good. 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 And good. Let's try another chip. Hopefully without shorts. We're not looking to add shorts to the board, we're looking to remove them. Waiting for the center pad to wet. Wait for the solder to grab. Center it up. Try to center that up a little bit better before we squish. Looks good. Looks good. Looks good. And looks good. Hopefully we have not acquired more shorts. Alright, no new shorts to report. At least on this side. Let's check our dust pads again. Ground. No new shorts. That doesn't mean everything is okay, but that's better than it was on the first try. Well, let's do some cleanup on this side before we flip over and do the work we need to do on the other side. We're flipping over and working on side B for a little while in the area that is targeted. And we just need to remove this solder from our pads gently. We are not pressing down, we're just putting enough pressure on to hold the wick to the board and gliding across these pads. You want to go with the pads in general. If you wick across these pads, you'll probably do something you'll regret. They are pretty weak, so just be gentle and go with them. I like running jumpers as much as the next guy, but not if I don't have to. I'm going to add a ball of solder to our tip, and we're just going to run that ball over these pads. Not really trying to make contact with the pads. And the iron. If you make incidental contact, it's not a big deal. Nice puffy pillows. I managed to damage my knife tip. Boo. I don't have any light ports, so I will have to modify a standard port to fit the light, which requires me to grind off the top of the port. I don't have a good way of doing that on camera, but I will go do that off screen, bring it back, and go from there. Okay, that looks pretty close. I think it'll do. So we can proceed from there. We will have to clean this port out thoroughly before we plug it into power, just to make sure there's no metal shards inside the port. Let's prep our freshly modified port. I do believe these ports have become more available than they used to be. I might consider ordering some at this point, so I don't have to do that extra step. Now for my method of installation, we're going to do some prep. Now we'll put a shield over these connectors and put a little copper shim on top of that. There are a million different methods for soldering these ports. Do what works best for you. This is the method that gets me the best results, so that's why I use it. I've tried the other methods, I just don't feel comfortable with them. So we continue to use this one. The process of this method is to bring up the temperatures of the board enough to wet the solder. You do have to be patient, and you have to move the nozzle fairly rapidly so as you're not holding it on the port and burning plastic. You got to be a little bit patient. I'm just waiting for visual evidence that the solder has wetted. Now we're going to hold the port down, remove our heat, keep holding it down until we see visual evidence that the solder has dried. Okay, looks like it is dried. It will be the most delicate of nudge tests. and it feels like it's fairly solid. Let's remove our shims and shields. Make sure we didn't burn any connectors. All connectors look good. Check our outer pins. Sometimes when you're concentrating on getting that inner roll soldered, these guys can get neglected, but it looks like everybody is solid and happy. Switching to our micro pencil, ball of solder, get things started. And we'll feed in some solder. I will probably rub this in with the big chisel tip on the 120 as well. We're just trying to get things started here. It's a little easier to get the solder on there with the finer tip. Come in with the big tip later. Now we'll rub it in a bit. What we want to happen is the solder to climb up those legs. It'll follow the heat, so you need the heat to travel up them. That is perfect feed through. Excellent. Now we just need to clean thoroughly, and I mean really thoroughly, especially inside the port, and we'll be prepared to do some power testing. I hope you're getting value out of this video. Just a reminder, if you find you're not ready to tackle this, I do offer these services, both locally and mail-in. Just head over to micromage.repair, quick free quote, fill out the form, and I'll get back to you personally. If you mention this video, I'll give you 10% off on your repair. We've cleaned the port thoroughly and inspected it, and I think it's safe to do power testing. So we're going to plug in our OEM charger, and we're going to measure for 15 volts on both sides. 15 volts, switch to the other side. 15 volts on both sides, that's a good sign. We're going to switch to our modified iPhone power squid, which we have retrofitted with Nintendo Switch and Nintendo Switch Lite battery connectors. We're going to activate using our OEM, and what we're looking for here is just a steady climb in amperage with no hanging. Unplug. And we'll just watch the current here, PSU channel 1, and that looks promising. Excellent. Our next step will be to reassemble the switch enough to test and go from there. We have it assembled enough to do some testing. It's back up and running, fan is spinning. We've charged this battery up to about 25%. Just to make sure it's charging on both sides. It is recognizing the charger on both sides. We know it's pulling 15 volts, and it's picking up our networks. Make sure it's picking up their game. And it is. All it's left to do is assemble and go from there. We are reassembled and everything's still happy. Well, I thought we were happy, but now we're not charging at all. It was recognizing both sides moments ago. I don't know what the heck's going on, but it's not activating at all. Now we're stuck on the Nintendo Switch logo. Okay, I guess I'll disassemble and see if I can figure out what's going on. I've hooked up our power squid. I just want to see if it will activate on it. Are we having a battery problem or are we having a real problem? Okay, it does power up on the squid. I may stick this battery on our battery refresher, assuming I can find it. The one that Roy designed for me. My only complaint with this thing is it's a little awkward to plug in a Lite battery, but we'll get there. Getting very unusual behavior on the trickle charger. Keeps jumping back up to 0.74. Usually when they're charging correctly, they charge and then they just steadily drop milliamps from like 74 to 73 to 72. This one seems to be jumping all over the place. I'm fearful we have a bad battery. I don't really keep those in stock. I generally deal with board problems. We definitely have a bad battery. We've been sitting at -4 dots here for a long time, and it just sits here and keeps cycling the amperage. I've never seen it do that before. So I will have to contact the client and let her know that I think we have a bad battery. I'm going to go ahead and plug up our squid and just make sure it continues to boot up and continues to activate with the OEM. It's not intermittent or anything like that. And go from there. Have our power squid plugged in. We're looking at PSU channel 1. I just want to make sure that it activates with the charger, powers up, and I'm going to do it on both sides. Without issue. Okay, shut it back down, flip it over. Turn it back on. Make sure it activates on the other side. Okay, it's seeing the charger. It's booting, it's not sticking on the logo. So it is recognizing the charger on both sides. And as you can see on the OEM, we are drawing 15 volts. It's been a few days and our new batteries come in. And I just want to confirm that we're not having a problem with our tester. So we're going to plug it in, click it on, and let it charge for a little while. What we should be getting, if everything is working as it should be, is pretty steady current that drops at a pretty steady pace. It's a little more random than I would expect, but it's staying kind of in the general area, and then it should just steadily drop, slowly dropping down a milliamp or 10 milliamps or so at a time. The other one was cycling. It would drop relatively quickly, and then it would go all the way back up to 0.8, and then it would drop again. I'll come back when it's down to 60 something, and we're just steadily dropping down. We're down to 0.68 now, so I believe this battery is working normally, whereas their battery was not. So I think our original diagnosis is correct, but there's only one way to find out, and that means we're going to have to very carefully take out their battery and see if we can figure it out. We're going to be very patient. Not trying to force anything here. Just trying to lift it up a little bit at a time. The adhesive on these things is no joke. Battery peeling is not something I normally do. Welcome to no fun. Good news is I kept some of the squeeze bottles I thought I got rid of. Hopefully this will assist in our endeavors. There's some alcohol in here. I'm feeling this is going to test my willingness to be patient. You don't really have a choice on this stuff. Made a little bit of progress. Let's pour some more alcohol in. Our slow, patient method here. Not trying to force anything. We're not wanting to break anything. We're definitely not wanting to set a battery on fire. Okay, I feel like we're making progress in here. Work it in there. All right. Excess alcohol off. Just don't want it to leak over or fall through any of these holes into the screen. I truly hope this solves the problem. All indications are yeah, but sometimes they can throw you a curveball. I'm not going for perfection on the residue. I'm going to grab a bag or something to put over this just so it doesn't stick to the new battery. I want to do some testing with the new battery before we commit. Stuck a static bag in there for the moment. Put in the new battery. Plug in the ribbon. We've hopefully not damaged in our efforts. Okay, I want to see normal charging on both sides. Okay. It's recognizing on this side. Let's flip it around. And it's recognizing on this side. Okay, I'm going to let this sit for a little while. And we'll come back assuming it stays functional. So it looks like we're fast charging. We're still keeping an eye on it though. So I want to make sure it doesn't die off suddenly and then not power back on or get stuck on the logo like it was before. I want to make sure this was actually a battery issue. And we're still charging, so it's not fallen off, it's not disappeared, it's not stopped recognizing the charger. I will probably switch to the OEM now and make sure it recognizes it both ways and continues charging. I want to be thorough with this testing, so I don't want this thing coming back. The child values it greatly, so we've got the OEM charger hooked up. I got the USB meter on it. I can't really test it both ways on this USB meter, but we'll just keep monitoring and make sure it continues to behave and go from there. It's worth noting that by this period of time, we had already had weird issues with the old battery. The Switch Lite has successfully charged to 100%. It didn't take that long, so I'm going to say this is probably just fine. I'm going to button it back up, but we'll keep an eye on it just to make sure. We're definitely going to put the new battery in. Maybe I'm supposed to do it the other way. Tight fit. Our battery's in, and I will reassemble and go from there. This is the point where it didn't work last time, so let's go ahead and plug it back in. Make sure it actually powers on normally. Make sure it's still sitting at 100. Okay, no issues. Excellent. See it on both sides. Excellent. Okay, so that one was a little bit different. I'd never seen a fault quite like that with the battery causing it. Everything seems to be good now. If you got value out of this video, I think you'll get value out of this one, and I'll see you there. Until then, peace, love, and solder wig.